So I'm a geologist, and tonight's topic of deep time is one that I am intimately familiar with, that I've worked with for years, and that's really very fundamental and central to my career as a geologist. And so for me, when I talk about deep time, I think about a process and a series of events. So for me, time is kind of the narration of processes and events. Sometimes blatant narration, sometimes very coy. And as a geologist, I see this story of time from every substance of this earth. So every bit of sand, every rock, every hillside, I see deep time, kind of this process and this story of time coming out. So here I am, a geologist. I am a PhD candidate, as was mentioned, and I'm painfully close. I'm hoping to defend my dissertation in the next couple months, and I am surrounded by artists. And so I admit I feel a bit of an oddball on the speaker panel tonight. So as I was writing this talk, my reaction, my initial instinct was to write a data-filled, data-rich, beautiful talk. Something like this. Whoa, you should be amazed. Wow, let's all swoon over this data. This is fabulous, fabulous information. And it is in the currency of geology. So for a geologist, we love data. It is our currency, right? We love it. We work hard to get it. We get jealous when other people have more of it. And when we do get it, when we do get the data, we're very happy, at least momentarily, until we, see if it works out with our hypotheses or not. However, data for geoscientists is a currency of communication. And I find that part of my work as a geoscientist is working on improving the communication of topics such as this, information such as we have in this data here. And I think I have a laser pointer. Maybe I don't. Oh, we turned it off. Now I have a laser pointer. So when we have this style of information, it's great. It's like crack for geologists. We love it, right? I can look at this stuff all day. But in general, it's kind of hard to swallow, and it's really hard to relate to. So I know that this is telling me exactly the uplift history of the Wind River Range in Wyoming, not really communicating to the general person. So I decided, as I was writing this talk, to do something I've never done before and to give a data-free talk. Take a deep breath, sigh of relief. We can hear the, lower your blood pressures. Because I love data, and I work with data. I love moving it around. I love analyzing it, and I love weaving it together into the fabric of these mountain ranges that I study. And I was thinking about this. It was almost that exact phrasing that kind of gave me a pause. Because as an undergraduate student, to be in full disclosure, I studied geosciences, but I also studied fine arts. And so I have a double major, and my focus with fine arts was traditional colonial tapestry weaving. So large looms, it's great, all right? But one of the things that I've come to notice through my studies as a geoscientist is that art and geology come together in their creative process in many, many ways. As a geologist, I take tiny bits of information, little threads of information from the world, and I put them together into a narrative or into a story. It's the same kind of process as I do when creating a large weaving. So this process is kind of what I wanted to talk about tonight. All right, so how do we relate to deep time? That's a good question. I think all of us are trying to answer that today. And so for me, the first step in doing that is to shift the focus from me and to shift the focus from your human life scale. Because let's face it, our human life scale has very little play in the realm of a mountain range, which might be forming over 20 or 40 or 90 million years. And so how do we then, all right, so we can remove our human selves, how do we conceptualize time? So I'd like to take you on a little field trip for a moment. So take off your regular life glasses, your artist glasses, your accountant or public service glasses, just tuck them in your pockets, and put on a pair of geologist glasses. All right, and I'm going to take you through my thought process here as we explore some of the mountains of the Southern Rocky Mountains where most of my dissertation work has been conducted. So here we go, onto a field trip. We're hiking up Mount Wilson, which is the westernmost 14,000 plus foot peak in Colorado. And the first thing that I'd like to talk about, or I'd like you to notice with your new glasses, is that we see time here on many scales, right? We have the annual time scale of the grasses or the flowers. We have our decadal human scale. We have the scale of the trees, which exists on the 100 or perhaps in rare instances, many, many hundreds of years. Right? If we move back a little bit further, we have the 1,000-year time scale of our hill slopes or of these talus fields way back here. Talking about these mountains in the back, we have the million-year time scale upon which these mountains formed. It seems like, wow, million years, it seems like it's really, really long. However, it's pale in comparison to the billion-year-old time scale that forms the actual rocks that root these mountains. So to me, I look at this landscape and I see, even though these mountains might seem 1 million or 2 or 30 million years old, they're young and they're fresh compared to the rocks. Right? So we have this ability to transport ourselves through millions or billions of years pretty much with ease. And I say this, millions, billions, talus slopes, rocks, etc., very easily, right? But how do we as humans actually feel that time? Or how can we experience that time? So for us to move from passing through time, passing through a landscape where we see the effects of time, to feeling that time, I would say let's start looking at the individual processes that are going on in the creation of these mountain ranges. So as we're hiking up, we're still hiking up to this outcrop here. This is one of my favorite rocks. It's called the Telluride conglomerate. And it is outcropping at roughly 13,000 feet above its namesake of Telluride, Colorado. And from this one outcrop, we can tell a great deal about time and the processes of formation. So, oops. Here we are. We've finally made it up to the mountain. We are leaning against it, perhaps. We're panting heavily. Our lungs are burning. We have no oxygen. We're sweating. And we're plastered against this rock for dear life. Okay? So at this scale, we don't see a whole lot. We can see kind of a jumble. We can see some different grains. We can see that things are different colors, perhaps different textures. But this is where we start as a geologist, okay? We come and we put our noses right up close to the rock. We notice, say, the textures. We feel it. We take pieces of it. We might put some in baggies and put them in our packs to enjoy a ride down to our laboratories. In my work, I do analyses of minerals of apatite and zircon. They're microscopic. I have to grind these rocks up to find them. And it is from these microscopic, these tiny little bits, from which I am able to gather the raw material to then make large, sweeping statements and draw conclusions about the evolution of the entire mountain range itself. So we start very, very small. If we prop ourselves up a little bit further, we can start to see a little bit more. We can see a jumble of different sized rocks, different colors. We start to get some shapes. And we start to be able to see the plot line of the history of this unit, or of this environment in which this rock was formed. So we can see we have a volcanic clast, we have some granites, we have a metamorphic rock, And we begin to see that in this one area, we have rocks pulled from very different, unique formation environments, dumped together rapidly in one place, and then turned to stone. Okay, so we're starting to see a little bit more. If we move back even further, we begin to see the entire outcrop. And from hundreds or thousands of bits of information, we're able to pull out an entire masterpiece or draw an entire conclusion. So similarly, we went from a paint daub or brushstroke, brushstroke, brushstroke. We added up to a full painting. The same thing, we pull outcrop mineral, we put that together, and we are able to identify and create a kind of a masterpiece landscape. All right, so every sand grain or every outcrop is kind of like its own thread that we then weave together into the fabric of our geologic story. So if we pull back even further, we start to see time and millennia laid bare. We can experience this, all right? We can see in this billion-year-old granites forming the roots of these mountains. They form agonizingly slowly over millions of years. They formed, cooling their crystals slowly, slowly, slowly. We are able to see volcanic units that form these peaks that are eroded away now. How can we see that in our real lives? We see the volcanism happening in Papua New Guinea, the same perhaps style on a more massive scale of event that formed these mountain peaks. The conglomerate that we were just leaning against, and which we see it's paired over here and over here, we see that today in the modern flooding that we just saw in Arizona. Or if you're nerdy and like me, you watch like monsoonal flood events out of the Himalayas like YouTube. It's really exciting, but we get to see these depositional events which are the modern analog for these rocks. So for me, when I am able to see modern events, that is how I can witness and I get a feel for these historical geologic events. All right, in this same view here, we see the formation in the rock, formation of rock happening. All right, we see in this stream bed, we see the deposition of sedimentary material. We see soils forming as we have years or hundreds of years of deposition, decay, and accumulation of vegetation material. And we can actually see the very slow fractions of millimeters per year or so of erosion and degradation of these peaks. We're able to watch them being shaped and changed if we have the luck to be immersed in this landscape over perhaps our entire lifetime. So as we stand here, kind of over billions and millions of years, I think we become increasingly aware of our human lifespan, our human time scale, right? It's impossible not to be kind of humbled by a scene like this, right? And I kind of have to say that I realize that our human lives are very trivial in the scope of this landscape, all right, of hundreds or thousands or millions or a billion years. We lose our importance as humans. And so I kind of say, well, wait, I want to be important. I am important. I'm making important conclusions in my research on this, right? So we humans, we are impacting this earth in very real ways, and we want to stake claim to that, perhaps, or perhaps not, because we might be surrounded by the worry and angst of the results of our human impacts. However, as a geologist, I've made my home in this continuum of place and of time. And so even amongst this angst and worry of our modern lives, I kind of remain calm. And so I've realized that even if we do send our globe into the ultimate catastrophic pollution and global warming catastrophe apocalypse, which we could do feasibly, our Earth remains, okay? Our humanity perhaps will adapt, perhaps it will not, perhaps it will continue to exist or not. But the Earth will record our human activities and our human impacts on this Earth just as reliably and just as honestly as it does the crystallization of a batholith or the eruption of a volcano. And so she continues, our Earth continues to shape and to record all that happens, and it continues to tailor it, kind of out of our human control. Oops, I have two controls here. So you can put away your geologist glasses now. So thank you for letting me give you this little glimpse as to how perhaps one geologist might see it. I imagine each geologist sees it independently, but I see time as the iteration of processes and the narration of process, an event, and place. So I do want to say that as you walk through these galleries this evening, enjoying the artistic rendition of time, and as you walk about perhaps the city tomorrow, notice that you're surrounded by marble floors and granite walls, and if you look outside, the phenomenal mosaics that are out there. And take a moment to put your geologist glasses back on and try to think about what the story we have of time and place and event in each of these bits of stonework. Okay, so I would give you that mission. Or next time you're out a little bit later this fall and you're enjoying the foliage, which I've never had the opportunity to actually see, but I have seen pictures and it looks fabulous. Take a moment to realize and to look at the landscape. Look a little bit beyond the annual foliage scale and look at the pebbles, look at the mud that smears your boots, and look at the hillsides and try to think about the processes and the events that went on and that are going on today in this Earth and how you can experience this geologic time.
Okay. Thank you.